Welcome to today's lesson on the buildup of lactic acid as a result of vigorous exercise. In today's lesson, we will explore how our bodies respond to intense physical activity and manage the resulting biochemical changes. Then, we will focus on understanding how vigorous exercise leads to the buildup of lactic acid in muscles. We will also discuss how this accumulation results in an oxygen debt, and how the body requires additional oxygen to convert lactic acid into harmless carbon dioxide and water. So far, you have learned that anaerobic respiration produces lactic acid in animals. This knowledge lays the groundwork for understanding the additional metabolic processes that follow intense exercise. Understanding the buildup of lactic acid and the concept of oxygen debt highlights the body's remarkable ability to adapt to strenuous conditions. It sheds light on the importance of oxygen in metabolic reactions and helps explain why proper breathing and recovery are critical components of exercise. When we exercise, our muscles require a lot of energy to contract and perform. This energy is typically generated through a process called aerobic respiration, where oxygen is used to convert glucose into energy, along with carbon dioxide and water as byproducts. In an ideal situation, our muscles get enough oxygen to sustain aerobic respiration. However, during intense or prolonged exercise, our body might not be able to supply oxygen to the muscles quickly enough. When this happens, the muscles switch to anaerobic respiration to produce energy. Anaerobic respiration allows muscles to continue working without oxygen, but it comes at a cost. Instead of breaking down glucose into carbon dioxide and water, anaerobic respiration produces lactic acid. This lactic acid accumulates in the muscles, leading to a burning sensation and muscle fatigue. If the lactic acid isn't removed quickly enough, the muscles can become too fatigued and are no longer able to contract properly. After intensive exercise, the body accumulates what is known as an oxygen debt. This term refers to the amount of extra oxygen the body needs to oxidize lactic acid into harmless byproducts, carbon dioxide and water, and restore the muscles to their normal state. Let's consider a practical example: running a 400-meter sprint. During the race, your muscles rapidly use up oxygen to generate the necessary energy. But as you near the finish line, your body can't supply oxygen fast enough, so your muscle cells switch to anaerobic respiration and lactic acid starts to build up. This is why you feel a burning sensation in your legs and have difficulty continuing at the same intensity. Once the race is over, you're likely gasping for air and your heart is pounding. This is your body's way of repaying the oxygen debt. During this time, your muscles are working to clear the lactic acid and return to their normal function. Here are some important things to remember. The buildup of lactic acid contributes to muscle fatigue, which is why you can't sustain high-intensity exercise for long periods. Adequate rest and breathing deeply after exercise can help clear lactic acid more quickly. Regular training can improve your muscles' efficiency in using oxygen and delay the switch to anaerobic respiration. To summarize, we learnt how energy is required for muscle contraction during exercise and is usually provided by aerobic respiration. During intense exercise, muscles may not receive enough oxygen to sustain aerobic respiration and switch to anaerobic respiration, resulting in the buildup of lactic acid. This causes muscle fatigue and an oxygen debt, which refers to the amount of extra oxygen the body needs to oxidize lactic acid into harmless byproducts. This oxygen debt must be repaid post-exercise to break down lactic acid into carbon dioxide and water. Understanding this process not only helps in managing exercise routines, but also highlights the importance of proper recovery techniques in physical training. By mastering these concepts, students can better comprehend how their bodies respond to different exercise intensities and the crucial role that oxygen plays in maintaining muscle performance and overall endurance.